Good morning, seventh graders. We can start the lesson now, and let me go over real quick about your do now questions. Hope everything is clear on the do now. So there are 4 questions. Actually, the first one is a word problem. Let's say you sold like a bunch of coffee mugs, and each coffee mug costs like $3.50, and you like collected $115.50. And how many mugs you may be sold? Okay, so you need to figure out by using a division, I would say. And the next one is using a calculator. It's all you need to know is how to type these fraction numbers and negative numbers in the calculator and see. Oh, by the way, it's not about finding a result. It's about the subtraction sign. So the rule for subtraction was subtracting a number. It's the same thing, adding its opposite. So which one do you think? Adding its opposite means like adding second number's opposite. Okay, so the next one is converting decimals. I would recommend to use a calculator. And the last one is comparing two numbers. So one of them is fraction, the other one is decimal. So you need to rewrite each one of them like on the other type. I would recommend go with a decimal number, how you can convert this number decimal, and then you can compare these two numbers. Okay, so let's go back to our presentation. And today's agenda, we're going to talk about a new lesson. Actually, it's very fun. I really love this. And last year, 7th graders also love this, about repeating decimals. Okay, and we're going to review real quick about adding integers. I told you we're going to practice more about adding rationals and using a calculator about adding rationals. Okay, so we're going to do this today, and you're going to have only vocabulary review. It's just a video, you need to watch it, and after that you're going to have vocabulary cards to real quick review what is about adding integers. And there is an exit ticket, and that's all. Okay, so today's objective is, I can understand that every rational number can be converted to a decimal number. Okay, every rational number can be rewritten as a decimal number. So this is the one objective. The second one is I can represent fractions as decimal number that either terminate in zeros and repeat. So sometimes, like when we convert fractions to decimals, so there are 2 cases. One of them is like terminating, the other one is repeating. Okay, so we're going to talk about these 2 today. And the essential question is, how can you write repeating decimals in a shortest way? So there is a shortest way. So you're not going to surprise like when I show you this how you can rewrite in a shortest way. Okay, so let's start with the lesson now. So from now on, it's very important. Please pay closely attention and what we talk on the next slides. So the first thing, let's talk about the green box. Okay, so when we use our calculator, it's a 3/4, right? And if you use your calculator, it's a 3 divided by 4 actually. And let me write it, use a pencil and red one. So that's a very clear one. So negative, it's a 3 divided by 4. If you use your calculator, it's going to be negative 0.75. Okay, and that's it. So this is how you can convert fractions to decimals. All you need to do is like top number divided by bottom number. So the second one is negative 7 divided by 8. Okay, so okay, and let's get back my pencil. So it's going to be equals negative 0.875. Okay, and next one is 3 divided by 16. So I'm not going to write in the longest way now. Let's get like a little bit faster because we already know this stuff. And it's a 3 divided by 16. So it's going to convert to 0.1875. And if I use my pencil, 0.1875. And the last one is, so it's a 2-hole, which is 2 point. Okay, that's the easy way to convert. Now convert the fraction part. It's a 1/5. If you divide by 1/5, it's going to be 0.2. So it's going to be 2.2. So all these decimals, like look at this. It's just like a shortest way, right? It ending at some point. That means like another way to say it, it's terminating, which means it's not continuing. At some point it will end, like it's not going like number and forever. So that's it. So we call this kind of decimals a terminating decimal. terminating decimal, or another name is ending decimals. So it's not going forever. But on the other side, there are other type of decimals. I mean, when you convert, there are other type of results for decimals. For example, and let me show you for this one. So 1/3. That means it's a 1 divided by 3, right? 1 divided by 3. So if you divide 1 by 3 using a calculator, let me show you. If you divide 1 divided by 3, you're going to see in the result, like in the calculator, if you type on your calculator, you're going to see like 3 is going forever. So which means you're going to write it down 0.333, like I don't know how many times, but it goes forever. So I'm going to put 3 dot. So I think we talk about the meaning of 3 dot in math, right? It means like it goes forever. So 0.3333, it goes forever. And the same thing for the next one. It's a 4 divided by 9. And if you use your calculator, -4 divided by 9. So it's going to be like 4 goes forever this time, because as you see, like just they put this amount, but that means like goes forever. Okay. And let me write it down real quick. It's going to be -0.44, and 4 and dot. Okay, so the next one, 1 divided by 11. If you use your calculator, I apologize, guys, you're typing in the chat box. Yes, thank you so much. Yes, it is a 4 goes forever. And if you try the next one, let me put the chat box right here so I can see your answers also. If you are okay, so the next one is like converting fractions was again top number divided by bottom number. Thank you so much. It is a yes, 0.090909, and let me write it down. It's a -0.09. So it looks like a 09 repeating this time, not single digit. It's just 2 digits are repeating, 09 and dot. Okay, so the last one, could you help me out on the last one so we can save our time? And it says what? 142857. 14. Yes, it is a how many digits? It's too much digits repeating this time. So it's a 0.14282857. So these, how many digits? 6 digits are repeating this time. If you use a calculator like a scientific calculator, you will see that 6 digits are repeating in this division. Okay, and 7, and it goes forever, like dot. So this kind of decimals we call like it's never ending, right? That's why we call it non-terminating, means non-ending. It goes forever. That's why you're going to see 3 dots most of the time in the problems or examples. And we also call it like a repeating decimals. And what decimal repeating? It's a 3. For this one is a 3 repeating. For this one is a 4 repeating. For this one is a 09 repeating. And for this one is like a 6 digits repeating, like 142857. Those 6 digits are repeating. But there is an easy way to rewrite this kind of numbers, and we call it like a putting a dash on the top of the number. And let me show what I mean. So let me use this time a text. So let's say, so instead of writing 333 forever, let me use this one again because I cannot draw a dash. So easy way to write this, like just put 0 point and write it down once, that repeating number. So 3 repeating, I'm going to write it down that repeating number once. And on the top of that number, I'm going to put this kind of dash. So that means like I can see that this 3 is repeating forever. Whenever you see this dash, that means under that dash, whatever the number you're seeing, that number repeats forever. Okay, so for the next one, for example, it's a -0.4. So because of the 4 is repeating in here, I'm going to put a dash on the top of 4. Okay, that means like 4 repeats forever. Okay, so this is the shortest way to rewrite it, repeating numbers. If you remember in the objective, we talk about like we're going to learn how to write shortest way repeating numbers and determine. Okay, so the next one, it's a 0 point. What numbers are repeating this time? Not single. if you see, it's 2 digits are repeating, right? So you're gonna write it down that repeating number once, but you're gonna draw the dash on the top of these 2 digits. Look at this. This time, like 2 digits are repeating. So you're gonna make your line a little bit longer because it has to cover these digits. So you understand that 09 repeats forever. Okay. For the last one, it's a bit of longer this time. You're gonna draw longer digits like 1, 4, 2, 8, 2, 8, 5, 7. Okay. 5, 7. So this time, like 6 digits are repeating. So because of that, you need to draw like a longer line. So under that line, under that dash, so these digits are repeating forever. So this is the shortest way to rewrite repeating numbers in math. Okay. And hope you got, this is the key point of today's lesson. So when I ask in the exit ticket, what did you learn? You learn repeating decimals and how to rewrite it in a shortest way and how to know repeating decimals in the math. It's just seeing a dash on the top of those digits. Okay, that's it. So it's that much easy. And if we move on, and this is about today's lesson. So let's see what we have in the next slide. I'm going to clear out this. Don't worry about, you're going to see this slide in a YouTube video after the lesson. I'm going to post it. Yes. Okay. So fractions. So the next thing is fractions represent terminating or repeating decimals. So, and you may ask me, like, how do we know when we have a fraction it's a repeating or not? How do we know, like, immediately can like say that the fractions can be repeating decimals or not? So there is the easiest way to realize it. I thought you also need to know this, and it's so the answer is usually when you're dividing numbers, when you're dividing any numbers by prime numbers or the number that has a prime factors, okay, but other than 2 and 5, because 2 and 5 are special numbers. When you multiply them, it's going to be 10. So it's other than 2 and 5. Any prime numbers, when you divide them, it's going to become a repeating number. For example, so you're dividing 1 by 3, right? 3 is a prime number. That's why this is a repeating number. That's why it's a repeating number. Let me, yeah. So this 3 is a prime number. That's why it's a repeating number. Like when you convert to the decimal, it's a 0.3. 3 repeats forever. Okay. So I'm going to put a dash on the top. For the next one, so 9, it's not a prime, but it's a number that has a prime factors. For example, 9 is a 3 times 3, right? 3 times 3 means like 9 has a factors of prime number 3. So which is, it contains a prime number. So this is also a repeating number. For example, like if you divide 4 by 9, what do you think it would be? Yes, 4 repeats forever. Thank you so much. You got it. So it's going to be like 0.4 and 4 repeats forever. Did you see it? So sometimes you may say that, okay, 9, it's not a prime, but the 9 has a prime factors. Okay, it's the same thing for 14. So 14 is a 2 and 7, right? I told you like a 2, like other than 2, but if you cross out 2, but still it has a 7, so which means like they have a factors of another prime. So that's why 2 divided by 14, it's also a repeating number. It's a very long repeating number. It's the same thing on the previous slide. It was something I forgot. It's a 2857, 142857, I think. So yes, this is the longest repeating number, one of the in math. Okay, so that's the key point. Yeah, thank you so much. You got it. That's the key point. Like if you divide any number by prime or a number that has a prime factor other than 2 and 5, so those fractions are become a repeating decimals. Okay, so this is another fact that you need to remember for today. And other than this, so let's see what we have. Okay, so let's practice about using rational numbers, number conversions in problem solving. So sometimes, like, let me announce this, this Thursday, upcoming Thursday, you guys will take a benchmark test because we finished our units and it's going to be an assessment. So we're going to talk about more about the expectations for the assessment and how much it will affect your overall grade. So for now, I'm going to review every day, today, tomorrow, and Wednesday. Please make sure you come on the Zoom sessions because I will ask very similar questions that I am reviewing right here. Okay, and this will be very beneficial for all of you. And let's try this example. So it says Eric and 4 of his friends. So how many people total? Eric is 1 and plus 4 more. So total 5 people in here. Okay. So this is the one thing, one key detail. That's why I highlighted. Are they taking a trip across the New York State Thruway? They decide to split the cost. Splitting means like a dividing, right? That's why I highlight the action as a green of the tolls equally. If the total cost is $8, how much will each person have to pay? So total cost is 8, and my action is splitting the cost, which is dividing. I'm going to use a fraction this time. By how many people? There are 1 plus 4, total is 5. Okay, so like just figuring out $8 by 5 people. How many dollars per people have to pay? This is a unit rate, by the way. So if you divide this, it's going to be 1.60 cents, like $1.60 per person. Okay, thank you so much. Somebody got it. So the next one is, yes, you got it. Next one is just before leaving on a trip, 2 of Eric's friends have a family emergency and cannot go, which means like they're not going. So how many people in total? So total was 5, and 2 of them are saying, I'm not going because I have a family emergency. So now it becomes like a 3 people, right, in total. So let's not get confused. This belongs to here. And what is each person's share of $8 toll? So again, it's going to split it like $8 divided by total is 3 people. So now you're going to divide by 3. Remember, because if you're dividing by prime number other than 2 and 5, this decimal become a repeating decimal. This is how you can see in your in your everyday life, like when you split it. So we're going to most of the time we round it, because if we're talking about money to the cents, which is hundreds place, and somebody got it, it's a 2.6, the dash on the top. Yes. By the way, 6 you said? 2, yes. And yes, it is 2.6 and dash on the top of it. So $2. Another way to round this, let me put the dollar sign in front, 2.6 dash on it, because 6 is repeating forever. And if you round this, it's going to be $2. And because of 6 going like forever, so if you round the previous one, 6 is greater than 5, so the next number will be 67. Okay, so this is where you need like a repeating decimals when you have everyday life problems. Sometimes you need to split the money with the prime number of prime people, like the number of people that has a prime number. Okay, so this is where you will see the repeating decimals in your life. When you use your calculator, say, what? 6 is going forever. So what does that mean? So that means it's a repeating, okay? So this is the problem about you may see in everyday life, and this is how you do. It's just a basically division, and just be careful that what number you are dividing by. So it tells you whether it's repeating or not, okay? And the dash, this is the key thing. Like if you see a number on the top of a dash, the number that has a dash on the top, so that means like that number is repeating forever. Thank you so much. Like some of you got really quickly to the point. That's awesome. So if we move on, let's see what we have on the next one. So it's a we do part. So in the we do part, as I told you guys, we're going to do a review, like adding integers. So now everybody open up your chat box, see if you can remember these, okay? So let's start on the first one. What is the absolute value? What do you think? A, B, C, D, like absolute value is a number's opposite on the number line. Absolute value is a number's distance from 0. Absolute value is the sum of 2 negative integers. Absolute value is the sum of negative and positive integers. Okay, we have 1. What do you think, hybrid students? Some of them are saying C, some of them are saying B, some of them are saying no D, because exactly it's not definitely D. So if you guys remember, absolute value is it's a some of you got it. It's a B because absolute value, it's always represents distance from 0. Okay, you got it. Thank you. You guys, awesome. Okay, so remember, it's a distance from 0. Absolute value, it's a distance from 0. Okay, all the time, and result has to be positive. So distance always represents as a positive. Okay, so this is a review. And let's see on the second one. What do you think? How could you add -3 plus 10? Another way to say it, how could you add opposite sign numbers? So these are the options. What do you think? Somebody says C. Okay, what do you think? Somebody says C. Like, how could you add opposite sign numbers? So negative, this is 13 is negative, 10 is positive. Okay, we have, yes, when somebody says, okay, we have a lot of different kind of answers, but somebody got it right. Okay, let me tell you, you guys can analyze this. Okay, so it's definitely not A. It says add 13 and 10 and keep the negative sign in front of it. Okay, keeping the negative sign that's the right part, but adding, no. When you have opposite sign numbers, you always subtract from one number from another number. So you can automatically cross out A and B. Okay, thank you so much. Somebody typed a lot. Okay, so that's a C. It's because you subtract one number from another because these are opposite sign numbers, and you put always a bigger number sign, which is 13 is bigger than 10, right? That's why you need to put the negative sign from 13. Okay, thank you so much. Whoever said a C, you're right. Okay, so this is a review, by the way. Like when you have opposite sign numbers, you subtract from one another and you put the bigger number sign, which is 13 is sign, so which is negative. Okay, thank you so much. So let's keep going because this is the purpose of review. Like we need to remember things. Sometimes we will forget. Okay, and on the next slide, look at the number line. Tell me what do you think for this one? Remember, the arrow that's starting at 0 has to be the first number. Okay. So what do you think for this one? Which equation is shown on the number line below? Okay, everybody agree on this one. That's awesome. Yes, it is C because you have two things, two clues. One is the arrow that's starting at 0, it has to be your first number, which is 4, and final destination will tell you answer, it's a -4, which is the same thing for C. Thank you so much. Whoever said it's C, everybody agree on the same thing. Everybody got the same answer. Okay, thank you. Which is awesome. Okay, and next one is somebody already answered that. Next one.
A, it's A.
So when you have a same sign numbers, you add the values, but you need to put what? Common sign. So first number is negative, second number is negative, which means at the end you need to put the same sign. So that would become -16. Okay? Yes, it is B. Thank you so much. So keep in mind, when you add same sign numbers, you always put common sign. That's the key point. You need to put common sign in front of your answer. So if numbers are negative, put the negative. If numbers are positive, put the positive. Okay? Okay, let's move on. And so this is the adding rationals. I'm going to use my calculator this time. And let me show you the calculator again, because some of maybe missed this. So when you add rational numbers, all you got to do is just you need to know how to type numbers on your calculator. That's it. Everyone is muted now. Okay, so everybody see the calculator, right? And I'm going to show you on both of them, and I will be a little bit faster this time. So the first problem was my 1 minus 3/4. So I'm going to turn on my calculator. So 1, oops, clear out. 1 minus 3. So this fraction a b over c will make your numbers a fraction. Okay, so 3 over 4. So I did it. And the next number is plus negative 12 1/4. Plus, so this is the negative sign, negative 12. And I'm going to click this once. Oops, it's not 12 yet. 12 whole 1 over 4th. Okay, so all you got to do is you just need to type the numbers and hit the enter. You're going to end up with 12. Looks like, is it 12? Yes, it is a negative 12. Okay, so let me show you the same thing on this calculator. If you have, I saw some of you has this one, and it's the same thing. It's a 1 minus 3. So this time is like a b over c in the left bottom corner. This one is a whole. Oops, I didn't turn on. Okay, 1 minus 3 over 4 plus 12 and 1 and 4, and it's a negative. So you need to switch the sign after you type the number for this calculators. Okay, you need to click it, so it's going to switch the sign, and when you hit the enter, you're going to end up with the same result, negative 12. Okay, I still don't have a proper calculator. You guys need to try to get as soon as you can, because it's very important. I told you on the first week of the school year, you guys need to try to get one of looks like this. It's you can find in a Walmart, or you can find a used one in a Facebook or otherwhere. Maybe you should talk to your parents, because this is very important for you guys learning math this school year, because we'll be using a lot these kind of calculators. Okay, try to get one for yourself. For the second problem, we're going to move on. It's a 316 plus 20.3. Let's clear out. 3 whole 1 over 6 plus 20.6. I think that's the second number is a decimal. Oh, not 6. It's a 3, 20.3. And the last number is minus negative 556. Minus negative 5 over 6. Okay, so once you type all the numbers, if you hit the enter, you're going to end up with 29.3. Okay, let's confirm the same thing for the other calculator. It's a 3 whole 1 over 6. Okay, and plus 20.3 minus, and the last number was a negative. It was, what was that? 556. 5 over 5 over 6, and you need to make it negative. And when you hit the enter, as you see, you guys will end up with the same result. Okay, and the last one, not last one, I mean, we're going to keep practice a couple more. It's a 16 over 20 minus negative 1.8. So 16, this is over, oops, 16 over 20 minus negative 1.8 minus 4 over 5. Minus 4 over 5. So once you type all the numbers, if you hit the enter, you're going to end up with 1.8. Okay, and the same thing for this calculator. It's a 16 over 20 minus negative 1.8 negative. The last one is minus 4/5. Minus 4/5. It's as you see, you guys will end up with the same result. Okay, so one more time, let me show you the last one is easy because it's a decimal number, an integer, negative 24. So for this one, we need to click negative 24 and minus negative 1/2. Okay, the last one is minus 12.5. Minus 12.5. Okay, so you're going to end up with negative 36. The last one is 24 negative minus 1 over 2 negative, then minus 12 point something. Let me double check. It's a 12.5. 12.5. And by the way, is it positive? Yeah, it's a positive number. So you're going to end up with the same result as you can see. It's a negative 36. Okay. So this is all about like for every fraction, adding and subtracting, try to use a calculator. And this is we recommend, and this is we expect from students learning how to use calculators, okay, for rational numbers. It's very important. And if we go back our slides, let's see what we have. So this is about the review for adding rationals, okay? And the next thing, oh, that's it. This is about today's lesson. If you guys can click this, and you're gonna have a video and vocabulary game for vocabulary. It's just a 3.5 minute video and then vocabulary cards that you need to go like review quickly. And then make sure you turn in your assignment on a Google Classroom. And for the grading, you need to check the rubric. And this is very fun. I really love this when I watch the video. It's very interesting. I mean, they review very good by like singing a song, okay? So then the last thing, it's about all you need to remember, all rational numbers can be represented as a decimals, either like terminating decimals or repeating decimals. And the other thing you have to know is we can represent repeating decimals by placing a bar over, like a dash on the top of the number. Okay, so this is the review for today. And before you go, there is an exit ticket. So before you go, you have two things. One is your vocabulary. It's just a video and vocab game. And the last one is exit tickets. And exit tickets, so there is only one question. Let's see if you understand this, like repeating decimal. Which one do you think? And tell me what you learned for today. And I mean, this one is like, what do you get confused for today? I changed it. And the last thing is like a checklist. Just put a multiple things, like if you complete them all. And that's all. Okay. Thank you so much. I'm going to stop the recording now, and I'll see you